Ever wonder how we figured out the laws of motion, the ones that govern everything from a thrown baseball to the orbit of planets? It all comes down to the brilliance of one man, Sir Isaac Newton. But his contributions go far beyond just a few laws. So, what are the benefits of Newton's work? Why are we still talking about him centuries later? That's exactly what we're diving into today. Before we get into the specifics, it's important to understand the world Newton lived in. It was a time of scientific revolution, a shift from relying on ancient philosophers to observing and experimenting. Think of it like this. Before Newton, many explanations for natural phenomena were based on guesswork and tradition. Newton, however, brought a new level of rigor, a focus on mathematical proof and empirical evidence. He wasn't just theorizing, he was building a framework for understanding the universe. So, let's unpack the benefits. First and foremost, Newton gave us the laws of motion. These three laws are fundamental to classical mechanics, explaining how objects move and interact. The first law, the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Think of a hockey puck gliding across frictionless ice. It'll keep going until something stops it. This might seem obvious now, but it was a revolutionary idea at the time. The second law deals with the relationship between force, mass, and acceleration. It basically says that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to its mass. In simpler terms, a bigger force will cause a bigger acceleration, and a heavier object will require a bigger force to achieve the same acceleration. This law is crucial for everything from designing bridges to launching rockets. The third law is perhaps the most famous. For every action, there is an equal and opposite reaction. Think about jumping. You push down on the earth, and the earth pushes back up on you, propelling you into the air. These laws, seemingly simple, are the foundation for understanding a vast range of physical phenomena. Beyond the laws of motion, Newton also developed the law of universal gravitation. This law states that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In essence, this law explains why planets orbit the sun, why the moon orbits the earth, and why apples fall from trees. It unified celestial and terrestrial mechanics, showing that the same force governs both the heavens and the earth. Before Newton, these were considered separate realms. He showed they were connected. But Newton's genius didn't stop there. He also made significant contributions to mathematics, developing calculus. Calculus is a powerful tool for understanding change and rates of change. It's essential for solving problems in physics, engineering, economics, and many other fields. Imagine trying to calculate the trajectory of a rocket without calculus. It would be incredibly difficult, if not impossible. Newton's development of calculus provided scientists and engineers with a new language and a new set of tools to explore the world. And let's not forget his work in optics. Newton conducted experiments with prisms, demonstrating that white light is composed of a spectrum of colors. He also invented the reflecting telescope, which uses mirrors to focus light, allowing for clearer and more powerful observations of celestial objects. This invention was a major advancement in astronomy. Now, you might be thinking, okay, Newton did a lot. But how does this benefit me today? The truth is, Newton's work is the bedrock of much of modern science and technology. Think about it. Cars, airplanes, computers, smartphones, they all rely on principles rooted in Newton's laws. Even something as simple as throwing a ball involves Newton's laws of motion. His work is so fundamental that it's often taken for granted. Consider space exploration. Sending a rocket to the moon requires precise calculations based on Newton's laws of motion and gravitation. GPS technology, which we use every day, relies on the principles of relativity, which built upon Newton's work. Even the design of buildings and bridges requires an understanding of forces and mechanics, all stemming from Newton's insights. Newton's influence extends beyond just physical sciences. His emphasis on observation, experimentation, and mathematical rigor has shaped the scientific method itself. His approach to problem solving, breaking down complex problems into smaller, manageable parts, is still used in many fields today. He showed the power of reason and logic in understanding the world around us. Furthermore, Newton's work inspired generations of scientists and thinkers. He laid the foundation for classical physics, which paved the way for later developments in modern physics, including relativity and quantum mechanics. His ideas challenged existing beliefs and opened up new avenues of inquiry. He encouraged a spirit of scientific curiosity and a pursuit of knowledge that continues to drive scientific progress today. It's also important to acknowledge that science is a process of building upon previous knowledge. Newton didn't work in a vacuum. He drew upon the work of his predecessors and contemporaries. But his contributions were so significant that they marked a turning point in the history of science. He synthesized existing knowledge, developed new theories, and provided a comprehensive framework for understanding the physical world. So, the benefits of Newton's work are vast and far-reaching. He gave us the laws of motion, the law of universal gravitation, calculus, and significant contributions to optics. His work underpins much of modern science and technology, from the devices we use every day to our understanding of the universe. He not only provided answers but also inspired a way of thinking, a scientific method that continues to guide us. His legacy is not just in the formulas and equations he developed, but in the profound impact he had on how we understand the world. With that said, thanks for watching, and until next time.